कहीं घूमने चलते हैं। कहाँ जाया जाए? जयपुर या मुंबई? दिन में गर्मी बहुत ज़्यादा रहेगी तो रात को निकलना चाहिए। पर रात में कितनी ठंड होगी, उस हिसाब से कौन से कपड़े रखे जाएं? एक काम करते हैं, ट्रैकिंग के लिए चलते हैं। पर अगर बारिश हो गई तो फिर ट्रैकिंग के लिए भी नहीं जा पाएंगे। अरे ये तो सही में बाहर बारिश हो रही है। हे भगवान, 1 महीने बाद अब कपड़े धोए थे सारे गीले हो गए। पता होता तो कल ही धो लेती, कल कितनी बढ़िया धूप निकल रही थी। एक मिनट, अब मैं ट्रिप पे क्या कौन से कपड़े लेके जाऊंगी?
मौसम बहुत नॉर्मल सी चीज, रोज सुनने की आदत पड़ गई है। पर अभी भी बहुत इंपॉर्टेंट चीज, हमारी डेली एक्टिविटीज इसके हिसाब से अभी भी प्लान होती है। भले ही टेक्नोलॉजी आसमान छू चुकी हो, लेकिन फिर भी हमें मौसम को प्रिडिक्ट करने की जरूरत है, क्योंकि कैसे पता चलेगा कि कहाँ पे घूमने जाना है और कैसे कपड़े लेके जाने हैं। कैसे पता चलेगा कि कपड़े धोने हैं आज या नहीं धोने हैं, क्योंकि इंडिया में तो अभी भी कपड़े धूप में सुखाए जाते हैं। इस वजह से आई हैव मेड दिस वेदर प्रिडिक्शन मॉडल। और गर्मियों में तो आप कोई चीज बाहर रख के छोड़ भी नहीं सकते हो किचन में ज्यादा देर खाने के लिए। क्यों? क्योंकि वो जल्दी खराब हो जाएगी अगर टेम्परेचर बहुत ज्यादा हाई है, और फिर कोई उसे खा भी नहीं पाता है, वो चीज जल्दी खराब हो जाती है। तो इस वजह से हमारे लिए बहुत जरूरी है कि हम टेम्परेचर और रेनफॉल प्रिडिक्ट कर सकें। वेदर के ये दो एसेंशियल एलिमेंट्स हैं। So that's why I have created this weather prediction model, which is a part of the course PHC 351 Fundamentals of AI or ML, under course instructor Professor Mayank Goswami sir. Uh, his name is on the slides, like everything is there on the slides, but थोड़ा वो स्क्रीन के साइज की वजह से कुछ डिटेल्स छिप जाएंगे इस वीडियो प्रेजेंटेशन में, बट यू प्लीज लिसन क्लोजली टू मी एंड आई विल मेक श्योर दैट आई कवर एवरीथिंग. What I have done in this project is that I have specifically created a model for Roorkee, my current place of residence, to predict maximum temperature and rainfall based on some actual past values. And this model is a linear regression model. Weather prediction is a real world application of machine learning. All the weather forecast stations use machine learning to predict the weather of the coming 1 day, 7 days, up to 10 days, or maybe more. What is the workflow of my project? Data acquisition and environment setup, data cleaning, EDA, dividing the data set into training data, test data, and validation data, feature engineering, creating a climatology baseline model, which is a simpler model just for comparison purposes, a linear regression model, and then comparing both of these models, analyzing their results and performance, and at last creating an interactive user interface in which the user can enter a target date to obtain its forecast. So let us start with data acquisition and setup. I downloaded all the data from the Indian Meteorological Department because it provides good quality data which covers whole of the country, and the data points mostly the data is very like high quality. I can show you the commands which I used for that. So this is the IMD library which is used to download the data. This command downloaded data of maximum temperatures from 2010 to 2024. It downloaded year-wise data and placed in a Tmax folder. I similarly downloaded data for rainfall as well, but that will be covered in the subsequent sections of this project. Then all the data which was downloaded in GRD files was converted to CSV, because GRD files are not easy to access. CSV files are easier to access and also to perform operations on. Now, how did I extract data specifically for Roorkee? Using this command. Can you see this latitude and longitude thing? You just go to Wikipedia, search a place for which you want to get the coordinates. I searched Roorkee. Here are the coordinates. The minutes section, the minutes portion, you divide by 60 to get a value in decimal, which has to be added to the whole degree number. This will get you latitudes and longitudes up to a fair resolution. Anyways, the IMD data has data points for latitudes and longitudes like 29.5, 77.5, which I can show you. Here it is. Where was it? This is maximum temperature for Roorkee. Latitude 29.5. This is the closest which I could get to 29.875. Similarly, for 77.89, the closest is 77.5. Next, the CSV file was downloaded. You can see I have printed some information about the downloaded data. Like there were 5479 entries, a total of 5479 entries, and the data spans 31 latitudes and 31 longitudes. The data is from 1st of January 2010 to 31st of December 2024. Okay, what did we do next? Yes, a clean environment was created in Anaconda, and then it was connected to Jupyter Lab to proceed with the work ahead. I can show you the Anaconda window. This command helped me to create the environment for this weather related project. What an environment does is that it has all the necessary libraries which you will be using for your work, but you do not need to save your project file, the file which has your code, into this environment. It can be saved in some other folder. Also, one thing to note that I used Python 3.11 version, not 3.13, because the latest version is not compatible with many scientific libraries such as IMD Live. Then we have to perform data cleaning after acquiring a data set, because the data, if you inspect, then you will most probably see some missing values, some gaps in the data. What happened with my data was that it does not have any missing values. It did not have any missing values because it was downloaded from IMD, and mostly they have do not have any issue with their data. That is also a reason why I chose IMD to download my data. How do I know that there were no gap values? Did I check the Excel sheet manually? No. I used this section of code to check for any missing values. Can you see this statement? This would have got me all the data entries which had a null value, which meant it did not have any data entry. So missing values were 0. This is how I knew that my data is already clean and I did not need to perform cleaning on my data set. Next is EDA, exploratory data analysis. This is meant to get a preliminary view of your data, like how it looks. This is very good for visualization. It helps you to visualize things. I'll show you how. So I have created 4 different kinds of plots. The first is a time series plot, then a monthly box plot. The third one shows yearly trends, and the fourth one is a temperature frequency distribution histogram. So this is the entire data from 2010 to 2024 plotted for temperature. Second is a box plot. I will not be delving into much details of a box plot, but just to highlight why it is a good way to visualize your data is that, can you see this box? The main box covers 50% of the data which is centered around the central value. This is the central 50% data from 25th percentile to 75th percentile. This is the 50th percentile. The minimum value is here, from which a line starts and meets the box. And the line which starts from above and meets the line which starts from above of the box, this ends at the maximum value which we have in the data for January. So we see the data from 2010 to 2024 for January, and the minimum value which we had got was this, like less than 10, maybe less than 5, around 5. The maximum value was somewhere around 24. Then this chart shows the average temperature for particular year around the whole year. And this is the temperature frequency diagram, which shows at which temperature we get maximum number of entries. So there are about 350 entries for a total of 15 years at a temperature around 33 degrees Celsius. What did we do? What did I do next? I divided the original data set into a training data set, a validation data set, and a test data set. So the training data set takes about 70% of the starting values of the original data set. The rest 30% is divided half into a test data set and a validation data set. Now I split these data, the original data set chronologically only, because we need a time series data. If had I shuffled the data, then it would not have given accurate results, because the temporal order of the data would have been violated. So what is the code to divide the data? Here it is. The training data set now has entries from 1st January 2010, 1st of July 2020, a total of 3,835 samples. Then the validation data set has entries from 2nd July 2020 to 30 September 2022, a total of 821 samples. The test dataset has entries from 1st October 2022 to 31st December 2024, a total of 823 samples. Next we go to feature engineering. So I created various features such as calendar variables and lag features. The calendar variables are useful to model the annual seasonality, because seasons depend on Earth's orbit around the sun, and our year is a solar year. By that I mean that our year depends on Earth's orbit around the sun. So, like, there is a direct correlation between the seasons and our year. So, each year, January will have similar kind of temperatures, not considering rapid climate change. Each year, October will have similar temperatures. The lag features I will be covering later as well, but okay, lag features take into account previous day values to predict next day. Next day. This is very obvious. If today temperature is, let us say, 30 degrees Celsius, then tomorrow it cannot abruptly drop to 20. So, taking past values into account is necessary when it comes to prediction of weather. I have used 1 day, 2 day, 3 day, and 7 day lag variables as predictors for the linear regression model. Showing you the relevant code snippet for feature engineering. Here it is. So from this create features function starts creating features for temperature prediction. This day of year, month and day, these are the date based features. Then we need these sign and cause functions to encode seasonality, because seasons are always in cycles. Sine and cos are sinusoidal functions which help to analyze the periodic nature of functions. These are the lag features defined here. So, next we go to the climatology baseline model. What is it? It is a standard practice in weather prediction. It just uses, like, let us say you have a particular target date in mind. Let us say 30 October. Then you take up the values, like the temperature values of 30 October for all the years from 2010, 2000, let us say 21. So you take average of all these values and declare this as the predicted value for 30 October any year. But this does not capture the immediate real-time conditions. What if the temperature for this year was somewhat deviating from the average? Then you will not get a good prediction. I have not created this technique myself. From what I have studied, I have got to know that this is already being used in some cases, but it is not that good. Showing you the code for that. By the way, this is not the model which I actually aimed to create. This is like setting a benchmark just for demonstration purposes. Later, the model which I actually intend to create will be compared against this one and we'll compare the results. So this is the code for creating the arithmetic mean based model. And if you would like to see the results, the best way to compare and analyze things is by using statistics, by using mathematical parameters, by comparing quantitatively. So I have used three parameters: root mean square error, minimum absolute error, and R2 score, R square that is. So you can see the actual temperature and climatology predictions. The root mean square error is this. This is mean absolute error. This is R square score. And this is the plot. So the plot is okayish. The orange one is climatology baseline. It is okayish. Because when there are great deviations in the actual data set, the baseline model is not able to predict that. Moving ahead, then I created the linear regression model. Linear regression, just a brief definition, it is a type of supervised machine learning algorithm that learns from labeled data sets and maps the data points with most optimized linear functions, which can be used for prediction on new data sets. How it is different from the earlier model, earlier technique, linear regression will use lag features, which means that it will depend on the days which just precede the target date. So the lag features which we have used, again, just to repeat, the lag features are of day 1, day 2, day 3 and day 7. This is the code part where I start making my linear regression model. I trained in it, validated it, and then on the test data set, I checked for the performance of my model. Now, do you remember the results for the baseline model? These are the errors. R square is not error. Errors have to be minimized to get better accuracy. R square is a score which has to be maximized. Errors have to be minimized. R square has to be maximized. Higher the R square, better are the results. Perfect score is 1, worst score is 0. So my linear regression model has to minimize its, like reduce its errors, decrease its errors to perform better than the baseline model. Has it been able to do this? Here I am running the cell, running the code. These are the results for linear regression. This is the cell, these are the results. And you can see this has performed better. The root mean square error is 1.432, mean absolute error 1.057, R square score 0.9487. And the plot excellently fits the actual data. very closely follows it because it depends on real data of just the immediately preceding days. Next, we'll compare both of them. So you can see the root mean square error. Oh, maybe I have okay, so there is a mistake here. For the climatology model, the root mean square error is 2.674, but for the linear regression model, it is 1.432. So the linear regression model has definitely performed better. I will better show it on the in the code. This is the portion where I have compared both the models. Now we are using a data set to which like the data set being used for testing both the models here has to be same. The see the test feet like test features data set is shorter than the original test data set because we have introduced lag features which reduces days by some short amount, in this case by 7 days, because of which we'll have to align the data set firstly. So okay, I will not cover the whole code here, but you can just see some snippets. This is the block which calculates improvements, and then I will also plot all the results. So here I have shown the results for first 10 days of actual compared with baseline and linear regression. Linear regression improves RMSE by 46.4%, that's huge. MAE by 47.8% and R square by 15.7%. And you can see a plot. Linear regression is the blue one, which follows the black one, actual temperature, very beautifully. The baseline is somewhat off the actual results. And next, I created the user interface, which I will okay, I'll show it on the code here only. So this is temperature prediction lookup tool for which you can search for dates from October 8 to December 31. This is the function which will get prediction with everything like error handling and everything. Just the date has to be in this range. You enter any date. I will run this snippet of code. So I'll have to enter any date. Let us say I enter 10 October of 2022. So this is the special format in which I will have to enter the date, otherwise the code will not work. 29.95 degrees Celsius with an error of 1 minus 1.14 degrees Celsius. Accuracy rating, very good. This is how I have defined the accuracy ratings. We can obviously change it as per our requirements. Prediction error is calculated, wait. This is it. I can also give it input of some other year. Let us say 2024 October, again 10. For this date, it has predicted 32.23 degrees Celsius, which is very close to actual data. So it has an accuracy rating of excellency, less than 1 degree Celsius. Similarly, I have performed the very same, I have like followed the very same process for rainfall data, obtained it for Roorkee, converted into CSV, again no missing values. generated a plot. I will rerun it. Generated a plot. This is it. And then split the data into 3 different files. Feature engineering again. Created the baseline model. I will run this cell again. The error here for rainfall is very large because see rainfall is one thing कि हो सकता है कल बारिश नहीं हुई थी, कल बिल्कुल साफ था खुला मौसम था, लेकिन आज बारिश हो गई. तो जो लीनियर रिग्रेशन मॉडल है वो प्रीवियस डेज पे डिपेंड करता है, और जो क्लाइमेटोलॉजी बेसलाइन मॉडल है वो तो अक्रॉस द ईयर्स एवरेज पे डिपेंड करता है. तो व्हेन इट कम्स टू रेनफॉल तब रिजल्ट्स इतने अच्छे देखने को नहीं मिलते हैं. लाइक यू कैन सी for the year 2022, actually there was good rain in October, the first half of October, but the climatology baseline model is trained over an average of many years. That's why it is not able to capture that. But when it comes to the linear regression model, it is very similar to the temperature thing. So I'm not gonna spend much time on the code, but just the results. The linear regression thing follows it closely, comparatively. And if we want to compare the results, so linear regression has improved as compared to the baseline model. Although not as much as we had for the temperature comparison, you can see the R square improvement here is huge. It is 276.2%. Because the R square for baseline was 0.1 and for linear regression it is 0.3763. Although none of the scores are good in their own, but if we want to see improvement of linear regression model above the baseline model, over the baseline model, then the improvement is really good. 0.3763 minus 0.1000 divided by 0.100 in 200 will give you percentage improvement, which is in this case 276.2%. And similarly, we have a rainfall lookup tool here. I'll simply enter a date which is in the range. Let us say 30 October 2023. So it is this format. And predicted rainfall is 0.12 mm. So this is the code part. Why did I choose linear regression? The target variable is a continuous numerical value that needs to be predicted, not a category, making it a regression problem rather than a classification problem that would require logistic regression. And linear regression provides interpretability. This is important. Interpretability through easily understandable coefficients, and it is quicker. Had I used some complicated model, then the data is not as large as would be appropriate for a large model. A large model, if trained on a smaller data set, will overly fit it. The predictions will try to follow the training data very closely, which will not actually give good results because it is not actually predicting. It is just kind of trying to repeat closely with the actual data. So linear regression here is better. It is quicker to train, easier to deploy. Now, I had not shown a comparison plot, like when we had a comparison plot for actual data versus regression data versus baseline data, then it is only for first 100 days. Why? Because अगर मैं ज़्यादा दिनों का लूँगी तो उसमें मुझे तब भी बहुत ज़्यादा जूम करना पड़ेगा क्योंकि वो रेजोल्यूशन खो जाएगा. So because we have to compare and see how both of them perform as compared to actual data. So that's why I could pick up any random continuous but sufficiently large portion of time and plot it. But does it mean that जो errors है यहाँ पे, जैसे कि RMSE, MAE, ये सब भी 100 days के लिए ही है? नहीं, ऐसा नहीं है, वो पूरे पूरे टेस्ट डेटा के लिए है. The final plot to compare both the models is based on first 100 days of test data, but RMSE, MAE and R-square values are based on the entire test dataset, which spans 27 months, which is more than 2 years. The reason of showing the plot for a limited time period is to better demonstrate how the linear regression models predict temperature more accurately than the baseline model. Had I shown the plot for 27 months, then the differences between the two models could not have been seen because of a very large scale and the loss of resolution. And I would have to zoom in to show specific parts. So, the statistics of errors are not just on this 100-day period, but they are on the entire test set. And why does the linear regression, or I should better say, how is it able to closely follow actual data? बिकॉज जैसे कि पहले भी कहा था कि जो क्लाइमेटोलॉजी बेसलाइन मॉडल है वो एवरेज वैल्यूज पर डिपेंडेंट है, लेकिन जो लीनियर रिग्रेशन है वो पास्ट 1 डे, पास्ट 2 डे, पास्ट 3 डे और पास्ट 7 डे की वैल्यूज, लेटर से टेम्परेचर वैल्यूज को लेकर अगला दिन प्रिडिक्ट करता है. तो दैट इज व्हाई इट क्लोजली फॉलोज, बट इट ऑलवेज फॉलोज, इट डज नॉट लीड. लेट अस से अगर एक बड़ी डिविएशन आती है एक्चुअल डेटा में, तो इमिडिएटली उसके जस्ट बाद लीनियर रिग्रेशन मॉडल में भी एक बड़ी डिविएशन आएगी, क्योंकि वो जो भी डे प्रिडिक्ट करना चाह रहा है उससे जस्ट पहले एक बड़ी डिविएशन एक्चुअल डेटा में आई है. और जो हमारा टेस्ट डेटा सेट है इट इज रिड्यूस्ड बाय 7 days, बिकॉज लेट अस से अगर मेरा टेस्ट डेटा सेट 1 अक्टूबर से शुरू होता है, तो रिग्रेशन मॉडल में 1 अक्टूबर प्रिडिक्ट करने के लिए मुझे उसके पास 7 days तक की वैल्यू चाहिए. तो 1 अक्टूबर से पहले का मेरे पास डेटा है नहीं टेस्ट डेटा सेट में, तो आई कैन स्टार्ट ओनली विद 8 अक्टूबर. 8 अक्टूबर के लिए मेरे पास पास्ट 7 days का डेटा अवेलेबल है. तो इस वजह से फाइनली जो प्रिडिक्शन हो रहा है जिस डेटा सेट पे उसमें 7 days कम हो जाते हैं ड्यू टू दीज लैग फीचर्स. और जो हमारा रिग्रेशन मॉडल है ये एक वैल्यू को प्रिडिक्ट करने के लिए पिछली जो वैल्यूज लेता है वो रियल डेटा की वैल्यूज लेता है. यहाँ पे मैं पिछले डेज की प्रिडिक्टेड वैल्यूज नहीं ले रही हूँ, क्योंकि अगर ऑब्वियसली प्रिडिक्टेड वैल्यूज में कुछ ना कुछ एरर होगा, भले ही वो कितना कम क्यों ना हो. और अगर सोचो 1 दिन, 2 दिन और 7 दिन पहले तक का जो एरर है उससे मैं आगे के डेज प्रिडिक्ट कर रही हूँ, तो जो एरर से पाइलअप होते चले जाएंगे. इस वजह से हम इन मॉडल्स में प्रिडिक्टेड डेटा नहीं लेते हैं. हम एक्चुअल में भी वेदर फोरकास्ट मॉडल्स में जब आगे के डेज प्रिडिक्ट करने हैं तो अभी तक का तो रियल डेटा ही लेंगे जो हमारे पास होगा. और जो इम्प्रूव रेनफॉल के स्टैटिस्टिक्स हैं उसमें इतना इम्प्रूवमेंट क्यों नहीं है, क्योंकि मैंने पहले भी एक बार ये मेंशन करा था कि रेनफॉल बहुत ज्यादा एक स्टेबल चीज नहीं है. इट इज वेरी मच पॉसिबल कि आज बिल्कुल भी बारिश नहीं हो रही लेकिन कल बहुत तेज बारिश हो जाए, और ये हर साल होगी ऐसा भी जरूरी नहीं है. तो बेसलाइन मॉडल तो ऑब्वियसली इसे प्रिडिक्ट नहीं कर पाएगा सही से. रिग्रेशन भी फॉलो करेगा, पहले के डेज को फॉलो करेगा, तो इस वजह से रेनफॉल को इतने अच्छे से प्रिडिक्ट नहीं करा दोनों मॉडल्स मतलब इतने अच्छे से प्रिडिक्ट नहीं कर पाए हैं. टेम्परेचर को ज्यादा अच्छे से प्रिडिक्ट कर पाए हैं, क्योंकि इफ टुडे इज 20 डिग्री सेल्सियस तो कल 25 से ऊपर नहीं पहुंच जाएगा एकदम से, या 15 से नीचे नहीं गिर जाएगा. इट विल बी मोर और लेस बिटवीन 17 एंड 23. बहुत शार्प चेंज नहीं आते हैं. अच्छा, और जो यूजर इंटरफेस मैंने दिखाया उसमें 2025 की वैल्यूज मैं क्यों नहीं निकाल पा रही हूँ, प्रिडिक्शन उसका क्यों नहीं निकाल पा रही हूँ, क्योंकि मैंने जो आईएमडी का डेटा लिया है वो 2024 तक के लिए ही अवेलेबल है. अब मेरा मॉडल रियल डेटा ही यूज करेगा, खुद से वैल्यूज तो जनरेट नहीं कर सकते, फिर तो प्रिडिक्शन अच्छा नहीं आएगा. 2025 का डेटा आईएमडी 2026 में रिलीज करेगा. दैट इज वाई अभी 2025 के रिजल्ट्स नहीं है मेरे पास. तो इसी से हम आगे के लिए कुछ माइलस्टोन्स रख सकते हैं कि अगर हमारे पास रियल डेटा अवेलेबल हो, रियल टाइम डेटा, तो हम उससे तुरंत अगले दिन के वैल्यूज भी प्रिडिक्ट कर सकते हैं। लेकिन अगर हम पहले से प्रिडिक्टेड वैल्यूज पर ही डिपेंड होकर चलेंगे तो हम उससे एक प्रिडिक्शन कर पाएंगे, बट उसमें एरर्स आने के चांसेस बहुत हाई हो जाएंगे क्योंकि एरर्स पाइल अप ओवर टाइम. Also, we can add other factors as well which are used to predict weather today, like humidity, UV index, AQI, etc. And अभी मैंने अलग अलग यूजर इंटरफेस बना रखे हैं, टेम्परेचर के लिए अलग, रेनफॉल के लिए अलग. ये बहुत जरूरी था क्योंकि पहली बात, मैंने जो प्रोजेक्ट है स्टेप्स में बनाया है. पहले मैंने पूरा का पूरा मैक्सिमम टेम्परेचर के लिए बनाया, उसके बाद मैंने रेनफॉल के लिए बनाया. दूसरी बात, फॉर डिमॉन्स्ट्रेशन पर्पसेस ऑल्सो इट इज बेटर, इट इज अ बेटर चॉइस to firstly show everything for one parameter, then I can repeat it very well, the very same way for some other parameter. तो हमने पहले टेम्परेचर देखा, फिर रेनफॉल देखा. फ्यूचर में इफ रिक्वायर्ड तो हम दोनों वेरिएबल्स को एक ही बार में इंटीग्रेट कर सकते हैं कि a user enters a date and the user gets all the parameters, the results for all the parameters at one go. So that was it. Thank you.